Hi, welcome to this video demonstration where we are going to look at the binary classifier SDCA Logistic Regression project 1. This basically is one of the binary classifier algorithms, logistic regression algorithms that is part of the Microsoft ML package. So let's begin. So before we go any further, let's look at the project's solution structure. So here we have the binary classifier SDCA Logistic Regression Project 1, and then we have certain dependencies, program.cs, that's what we're looking at here. And we have two classes here. One is called sentiment input data and sentiment prediction output.cs, two class files here. And then we have the training dataset called Yelp label.csv. I already have imported some of these files that we need, so I'm going to show you exactly how to do that. So before we begin, first we need to make sure that we have imported the Microsoft.ml package from NuGet.org. So let's select this, right click, and here you should see manage NuGet packages. So we're going to click that. You have to make sure that your computer is connected to the internet, and you have to select browse, and here we type ML for machine learning, and it lists a bunch of these machine learning options within the Microsoft ML package. So the one we are interested in at this time is called Microsoft ML, and we are going to select that. As you can see, when I select it, it shows a cross for version 1.1 and it shows an upload for version 1.2. That means that Microsoft.ml package has been updated from version 1.1, which is what I'm using right now, to version 1.2. So in your example projects, when you open them, they are all version 1.1, or maybe in the future they will be version 1.4 or 1.5 and so on. So it's better to check the latest package and then just select that package. In this case, Microsoft ML package. And on the right hand side, it basically gives the option of uninstall and update. We should just do update, and that should take care of the updating of the Microsoft.ml package. So let's do that. I'm going to click on update. And it basically says the updates will be applied to these libraries here. So click OK. And you can see the update has been done. And to make sure that the update has been done, we just open dependencies and we go to NuGet. And we can see that the package is currently 1.2. So the package has already been updated. So we are done with that part. And so the next part is going to be creating basically importing the training data file. In this case, we are going to use Yelp label.csv. This training data file basically has one column of text that is restaurant reviews on Yelp, and the other column is basically already classified positive and negative sentiments. Positive sentiment is 1. Negative sentiment is 0. I already imported this sample training data set as part of the solution here. If you have not done that in your case, all you have to do is basically select the solution, right click, and then you click add and go to existing items. And I have my sample data sets here in this folder. And you can see that it's Yelp.label, and I can select it here. Make sure that you can see it. Add to select all files. So you can see Yelp labeled. Since I already have added this as part of my solution, I'm not going to add this anymore. But in your case, you can do that to create your own solution. So I'm going to cancel out of this. And so you have the training dataset here. Two other class files have to be created. One is called sentiment input data, and the other one is called sentiment prediction output. Sentiment input data, I have already created that as part of the solution demonstration here. In your case, all you have to do is basically right click on the solution project and then go to add. From add, select new item, and on new item select class, and you can write the class name right here. I presume most of you already are familiar with creating classes, so this should not be any difficult thing to do on your side. And then you just add the class, and then you have to fill in the specific statements within that class here called sentiment input data. Similarly, you can create sentiment prediction output exactly the same way. You just select right click and then go to add, then go to new item and select class, and then write the class name sentiment prediction output, and then you are going to click add to add the class. So I've already done that. So your final structure of your project solution should like exactly like this. The other important thing that you have to understand is that you select Yelp label.csv, the training data set, and it shows the properties down here in this part of the Visual Studio. Under copy to output directory, you should always select copy always. There are several options here. You should select copy always. That is very critical for the dataset and training to occur as you develop your machine learning model. And that is true for all projects that you work on using Microsoft.ml machine learning package. So it should be always copy always. Okay. Having done that, let's first look at sentiment input.cs. In this class file, when you create it, several libraries will be automatically imported for you. Our most important library here is importing Microsoft ML.data library, and in this case using Microsoft ML.data. And then we have the project name, and then class sentiment input data. There are two properties here. One is called public string sentiment text, one is public boolean sentiment. So we use the load column annotation here, load column 0 and load column 1 column label. As you recall, the training dataset, Yelp labeled dataset, has two columns. One column consisting of sentiment text, the other one is binary classification of positive and negative sentiment. So that's why we have two columns, load column 0 and load column 1. All the columns from the training data file is indexed starting with 0. So the first column is 0, second column is 1. And the first column is going to be strings, and we are calling that public string sentiment text. And the second column is going to be Boolean, because those are either positive or negative sentiments, 1 or 0. So a public Boolean sentiment. We are specifying that's going to be second column, and we are specifying column name label for that column. So that's the sentiment input data. That means this is going to be the input data model to train our binary classifier SDCA logistic regression algorithm. The next class that we added was sentiment prediction output. From the name you can see that this is going to be the output data class that will be used by the algorithm to give us the output. So it's, again, similarly have some libraries already imported for you, but the most important one is using Microsoft ML.data. And then we have the sentiment prediction output class, which should be a subclass of sentiment input data. So it's going to be and then you have three properties here: column name predicted label, public boolean prediction get set, public float probability get set, and public float score get set. So we have three properties. One is prediction, one is probability, and score. So these three are the output that we expect from the machine learning model. So these are the two first classes we make, and then the last one that we are going to look at is program.cs, our main program file. So in this one we already have using system imported. One of the important one we need to import is using system.io, and then we import the Microsoft ML libraries. You have to make sure that you already have installed Microsoft ML package as part of your solution, as you have seen before. Now we have we are importing Microsoft ML, ML.data, ML.trainers, and ML.transforms. I made this explicit so that you can understand the different packages that are part of Microsoft.ml overall package. The next one we import is called Microsoft ML Data Operations Catalog Library. This gives us reference to the train test data object because we want to split the same training data set into into a part for training, another part for testing, and we'll take a look at that in a few minutes. So we use using static Microsoft ML data operations catalog. So we import that library here. Next one that we look at here is under class program. The first step is to declare a path to the training dataset. So we have the training dataset here. We want to specify the path. So we have static read-only string training data path, path.combine environment.current directory yelp label.csv. And the next one is declaring a path to saving the trained machine learning model, static read-only string model path, path.combine environment.current directory model.zip. Model.zip is going to be the trained machine learning model that we save, and we are specifying the path as model path. So having done that, we go under the main method here, and we create a method called classify sentiment. So once the main method runs, it's going to call the classify sentiment method. And outside of the main method, we declare the classify sentiment method here. We call that public static void classify sentiment. Within the classify sentiment, we instantiate the ML context object. So ML context, new ML context. ML context object is perhaps the most critical object in the Microsoft.ml package. It has a lot of properties that we are going to use as we develop these programs. Next, we look at loading the training data and splitting the training data into 80% for training and 20% for evaluation. This is a standard practice in machine learning and data science. So to do that, we basically first in step 3 create a iDataView object using ML context.data to load the training data set. And that's what we do here on step 3, iDataView, training data view, ML context.data dot load from text file. We specify sentiment input data class here, and then training data path has header false, separator character, comma. Has header false because in the .csv file you have no header. .csv file has the comma as the separator for the columns, and we specify the training data path here that we declared in the beginning over here. So that becomes an argument over here, and we specify sentiment input data class as our input data class. In step 4, we split the training data automatically into 80% for training and 20% for evaluation. So we use train test data. Train test data equals ML context.data train test split, and we specify basically training data view as an argument and test fraction being 0.2. Test fraction being 0.2 basically means 20% of the data will be set aside for testing, and 80% of the training data will be set aside for training. And that's what we do over here. And you can see we declared training data view object over here, and we pass that here as an argument. Then in step 5, we create a pipeline object to training the machine learning model. So we have var data preparation pipeline equals ML context dot transforms dot text dot featureize text. And since we are classifying text using binary classifier, from the transforms we select the text, and from text we select the featureize text method. Output column name is going to be features. Input column name is going to be name of sentiment input data dot sentiment text. Remember that one of the property in the sentiment input data class is called sentiment text, which is going to hold all the text read from the training data file. So that's what we are expecting here. That input column is going to be all sentiment text that will be featureized by this method into an output column called features. Then step 6, we have now we're going to create the SDCA logistic regression trainer using data preparation pipeline.append method. So we created data preparation pipeline here. We are going to use that here to create SDCA logistic regression trainer. So we use data preparation pipeline.append method. We then use ML context binary classification .trainers .SDCA logistic regression, and we pass the label column name label and feature column name features. Feature column name features is what we did over here as an output of data preparation pipeline. And label column is basically what we already defined as part of the sentiment prediction output class. In the next step, continuing is step 6. So it's a continuity, that's why I'm using the same number. Training a machine learning model using train test .train set. So var model, that's our training machine learning model. We're going to instantiate that using SDCA, Logistic Regression Trainer, that we instantiated here in this part of step 6, dot fit, and we pass train test data dot train set, and we instantiated that over here train test data set in step 4, and we are passing that here as part of the fit method, and we are choosing train set as part of the training of the machine learning model. Once we have done that, we go to step 7. In this case, we are going to evaluate and assess the trained model, meaning how well it performs. So in step 7, we are going to use train test data.test set. So we create a iDataView object called predictions for evaluation data view. Model.transform. So we use the model object that we created in step 6 here, model.transform, and we pass train test data.test set. So test set is 20% of the data that has been held over for testing the model to see how well it performs with data that it has not seen before. So we have predictions for evaluation data view. Then we move to step 8, and we create some evaluation metrics, and we use calibrated binary classification metrics, and we use ML context.binary classification.evaluate method, and we pass predictions for evaluation data view and label column name label. So we pass this object. As you can see, we created that here in step 7. We pass that as an argument over here for the evaluate method. After creating the metrics, then we go to step 9 to display the performance metrics. So we have the binary classification, trainer algorithm, SDCA, logistic regression, and the metrics that we use. So there are several metrics that are available as part of the macros.ml package, and it gives us various aspects of the performance, so we can really assess how well the model is performing. So these metrics are metrics.accuracy, metrics.f1 score, metrics.area under ROC curve, metrics.area under precision recall curve, metrics.log loss, metrics.log loss reduction, metrics.confusion metrics. This confusion matrix is very important. It gives us how well the model is performing in classifying the true and the false items. Metrics.positive precision, metrics.positive recall, metrics.negative precision, and metrics.negative recall, and then metrics. I got a repetition here, so excuse me for that. So these are the different metrics that we have here as part of the output. Then we move to step 10, where we want to input our own new sentiment text to test the model with a new set of data. In that case, we create a sample sentiment text, new sentiment input data, and we provide the sentence over here. I love this restaurant. Of course, Yelp dataset is a collection of restaurant reviews, and I have a sample sentence here. You can try different sentences and see how your model actually classifies the new sentence. So we create that input object here, and then in step 11 we create a prediction function, ml context.model.create prediction engine, and then we provide the sentiment input data class over here and sentiment production output object over here. So sentiment input data object and sentiment prediction output object, and then we pass the model that we created, trained model, as part of the prediction function. In step 12, we use the prediction function to get the prediction result. So prediction result instantiated as a prediction function .predict, and we pass the sample sentiment text that we created here in step 10 as part of the predict method over here. Then in step 13, we write some console.writeLine statements to see the prediction output in console. So we have prediction sentence. We want to see the prediction sentence. So we specify prediction result to sentiment text. Then we want to convert the binary result of 0 and 1 into positive and negative. So we use convert dot to boolean method here and pass the prediction result of prediction. And then we have given two options, either positive or negative, depending upon 1 is positive and 0 is negative. Then we also want to see the probability, so prediction result dot probability. And the last part is step 14, where we want to save the ML model for future use in developing applications, Windows app or mobile app. So in this case, we are using the file stream object, and we specify the model path that we created in the beginning of the program. File mode.create, file access.write, and file share.write. And then we use the ML context.model.save method, pass the model, and pass training data view.schema and file stream object, and we are able to save the machine learning model. So having done that, this is the end of the C# program for using binary classifier, SDCA, logistic regression. So now let's look at the output. So we're going to run the program. So here is the output in console. You can see binary classification, train algorithm, SDCA, logistic regression. Then we have the model quality assessments, accuracy, F1 score, area under ROC curve, area under precision recall curve, log loss reduction. Then you have the confusion matrix. We can see positive and negative recall and precision. And then we have the positive precision, positive recall, negative precision, negative recall, and so on. And you can see the model has performed fairly well. The area under ROC curve is about 90.38%. Accuracy is about 82%. The model can be improved, but I think given a first pass, this is not a bad model to work with. So that brings us to the conclusion of this demonstration of the SDCA logistic regression algorithm binary classifier. Hope you enjoyed the video demonstration. Thanks so much.